All right, this is the ANSYS final project for Fundamentals of Aero. I'm going to show you part C. Um, so to start out, I went into Airfoil Tools and plotted out NACA 2415 1000 millimeter chord. Just wanted to plot it out and converted it to a CSV file. Um, and then after that, you can go in here and import now once you get the CSV file, you're going to have to make it into a text file like this. So you'll have to input all the, this is your X coordinates and then your Y coordinates here. Do that. So then you can input that geometry as a, I'm sorry, no, you go to Edit Geometry and Design Modeler. So you have that text file. It needs to be a text file, it won't read a CSV, by the way. Then once you have that, I went in here and clicked on this point button right here, and then you can import. If I go over here to the points, you can import from that text file, and it'll put these points in. Then I made a line through these points and constructed a surface from them. And then I went ahead and made this boundary around here. This is your control volume. So I wanted to make it decently sized so we could make sure that it's, large enough to capture the proper calculations, whatever, in the simulation. So I went ahead and made it about 15 meters by 15 meters, just to give it some ample space to cover that. And then I went in and added these lines here. So I added a line down the center chord. I added a line coming down here that's going through the leading edge, and then a line here that is about 100 millimeters off of the leading edge. Sorry, this is the trailing edge, by the way. So the leading edge, this line is going to about 100 millimeters off of that. And they're all, I wanted to do this so we could split these up into separate sections for meshing. Makes it a lot easier. And I use this face split tool here to do that. Makes it way, way easier. And that's pretty much it for this. And then once we're done with that, we open up our mesh here. Try to. It's gonna take a second. All right. So we have our mesh here, and I'll just show you guys what I did first. So first off, for the name selections, we want to make sure we have our inlet selected. Went ahead and made a thing for that. So we clicked N to make the selection. Same for our outlet. There's two back lines. Symmetry, which is our walls, and then of course the airfoil itself. Um, Another thing that's important, so I started here with some mesh sizing. I did these lines here, and I went ahead and did 250 divisions and made up bias factors so it is more dense towards the center, towards the airfoil, because that's going to be better for our calculations later. Here I did these three lines, and I basically did the same thing, kind of like last time. Did the bias. This one's only with 150 divisions, with a much higher bias factor, so we can get some nice, good definition right here towards the back. And then I did the layers right here. So we've got top layers here, and then of course the airfoil top layers. See, it's separate from the leading edge right here. And I did the same thing. No bias on this one. I need it. And then of course the front, the last two edges, you got your front parts here, and then front leading edge. I went ahead and no bias, 100 divisions. And if this is what it ended up looking like, it's not a great mesh, honestly. I was messing around with it for like literally 5 or 6 hours straight, and I could not get it to be any better than this. I feel like this is as good as I could get it without banging my head against a wall. But yeah, that would be it for the meshing. Um, believe that's it. So then once you have your meshing done, obviously you can close that out, open up your setup, and it would look something like this. Um, Actually, it wouldn't look like this when you first come in, but let's see if I can get it to look like that, whatever. So we first start out, go ahead and we went to our models here. I changed this viscous model to this transition model. I found it ran the best and caused the least amount of errors, so I just went ahead and did that. Leave all the settings the same. Let's check to make sure that our fluid is right. We're given 1.2 density, 1.8 times 10 to the negative 5 for viscosity. So yes, that's correct. And then we'd go to our boundary layer conditions, and of course the only thing that really matters is our outlet here. And so we need to get a Reynolds number of 1 million. And with our chord length and our given viscosity and density values, we can use the Reynolds number formula to calculate a good velocity. And a really good velocity here would be 15 meters per second. So I'm just going to go ahead and do that. That'll give us that 1 million Reynolds number there. And went ahead and just did components so that we could change it later when we did the different angles of attacks. We could just change the component angle. And I actually got that in here. I calculated all of these because it's literally just, you just get the radians from these. You gotta convert it to radian, and then you can get the velocity really easily, just taking 15 times the cosine of that for your x, and then sine obviously for the y. Drag is just 1 times. Then this is just the opposite of drag. So yeah. So once that's good, that in, we'll click apply. Oh, for me to put a 0 there. Sure, that's still good. All right. That's it for the boundary conditions. For our reference values, I wanted to make sure you compute from the inlet here. Then went ahead and changed our residuals here. I added an extra 0 into here to make the residuals a little bit more clean, a little bit tighter. Report definition is an important one. We want to make sure we make some new report definitions so we can get our drag and lift coefficient. So you do like something like that, and then you would do it across the airfoil. And you name it obviously drag coefficient, lift coefficient, blah 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 blah. I already did that here for both the lift and the drag, so I'm not going to do it again. Okay, yeah, I think we're ready to initialize. So let's go ahead and go over here and run the initialization. All right, did it work? There we go. And then now we're actually ready to run the calculation. I did 300 iterations. I feel like that's plenty fine for conversions. So just go ahead and run that. Try to run this, see if it works for me. No, it would really suck if it didn't. Being really slow now. Yes, go ahead. Overwrite. Do what you need to do. That's why it was like, didn't know what to do. I'm not sure why our drag coefficient isn't being made. Or maybe it is, it's just not showing up. Interesting. It's converged. Done. It's trying. It's wanting to. Come on. There we go. Let's go to our residuals. Okay, so yeah, it didn't, for whatever reason, it didn't do the drag coefficient, but there's the lift coefficient. Is if I could figure out how to fucking get it back. Okay, yeah, you know how it'd be. All right, so that's how you get that. For your drag, again, I don't know why this isn't working. It's really annoying. Okay, yeah, so I'm not really sure what's going on with that. But yeah, it should give you this drag coefficient here. I don't know why it's not. It's really annoying me. And I can run the calculations again, but I don't know what I'm doing wrong. I can try it again. I just don't know why it's being difficult for me now. It's just using this like not too long ago. Why is it not writing? That's really, really, really annoying. Okay, but you know I'm not bullshitting you, alright? Yeah, that normally it would pop up here. I don't know what's going on. This is how you do the drag coefficient. You literally just do the opposite thing. I don't know why it's being really stupid right now. It's really annoying. But what are you gonna do, right? You know, sometimes there's just... Come on. Okay, so yeah. I mean, there it is again. I don't know why I can't move this. It's really annoying. But yeah, so we've got that. Let's go ahead and get a contour going for, obviously, for static pressure is pretty easy to figure out. And velocity. Boom. That's it. That's it. Easy as pie. So again, I don't know why the CD thing is not coming out correctly, but normally it would come out here. And you would come over here to your report files. And this is actually how you can get the... Yeah, okay, so I don't, again, this is like all sorts of messed up. Yeah, this is not. I don't really know why this isn't working now, to be honest. This is really annoying me, though. Is it this? Like, am I clicking on the wrong thing? Oh, yeah, that might actually. There you go. There's your computations there for 0. Fairly close to what I got earlier. So yeah, that's where we're at. And you would do the same thing, obviously. If you wanted to get your lift, you would go down here to this, and click compute. Boom, there you go. And then if you want to do different angles of attack, that's the fun part here. You have to go over your inlet. Ooh, I messed this up. Okay, that's why this is all sorts of funky. There you go. That's a better value. So yeah, if you want to go change, let's say to 3 degrees, then we can get our x velocity here. And that would go here. And then obviously you take your y velocity. Yeah, we'll go out. Just like that, yeah. Nothing at all. Nothing at all. And yeah. Once you have that, obviously you'll just do. We'll just click apply, and then we'd have to go down here and change these report definitions as well. You'll have to change these to the x and coordinate and the y coordinate for drag right here for 3 degrees. Same thing with your lift. You have to do that, and that's how you get the proper values. And then once you have all those values and go through all the iterations, you can come in here and plot them after you put all the data into a table, obviously, and then you can plot everything in respect to alpha degrees. Yeah, that's it. It's done. Goodbye.